question for all my doctors. When you get an anemic patient and you tell them they need to eat more beef, what else do you tell them? Because I know some of you know this, but it seems like it's not obvious knowledge, and I wish it was. Too much calcium is going to keep you anemic or cause you to be anemic.
First of all, that is a fantastic video, pointing out the fact that just because you are taking an iron supplement doesn't mean that you are absorbing it adequately, because there are multiple things that can actually inhibit proper iron absorption, including phytates, polyphenols, calcium, and oxalates, along with many others. In iron deficiency, anemia is the most common cause of anemia worldwide. Very briefly, anemia is characterized by a reduction in hemoglobin, hematocrit, or red blood cell count. Red blood cell count, as the name implies, is just the amount of red blood cells inside of your bloodstream. Hematocrit is the percentage of your blood volume that is made up of red blood cells. And finally, hemoglobin is actually a protein that carries oxygen found inside of your red blood cells. And this protein requires iron. This protein gives your red blood cell size and is required for optimal red blood cell function. An iron deficiency can cause what's referred to as microcytic hypochromic anemia, which is just a fancy way of saying we have small and pale red blood cells. This is because hemoglobin is both large and red, and inadequate production of hemoglobin due to iron deficiency reduces the size and red color of those red blood cells. Just in the case of iron, there are two main types of iron deficiency. Absolute iron deficiency anemia is caused when your entire body does not have enough iron. Therefore, there's not enough inside of your entire body for adequate hemoglobin and red blood cell production. However, a functional iron deficiency is when you have enough iron inside of your body. However, it is being sequestered into storage and there isn't enough available iron for the production of red blood cells, also known as erythropoiesis. This is also caused anemia of chronic disease because it is caused in large part by inflammation, which is heightened by things like kidney disease, heart failure, rheumatoid arthritis, and other conditions, and is diagnosed by having elevated ferritin, the protein that stores iron within your body. But you could have completely normal iron and still have anemia. That's because there are multiple micronutrients and multiple processes that are required for adequate red blood cell production that have nothing to do with iron. Vitamin A is important for regulating the gene expression of proteins involved in red blood cell production and breakdown, and vitamin A deficiency can cause anemia. Folate and B12 are required for proper red blood cell production, and inadequacies in these two micronutrients can cause macrocytic anemia, in which the red blood cells are abnormally large but there is a reduced quantity of them. Other B vitamins like thiamine, riboflavin, and vitamin B6 can induce iron deficiency anemia through multiple mechanisms, regulating the movement of iron throughout your body, the uptake of iron, and the production of hemoglobin and red blood cells. Both too much and too little zinc can cause anemia. That's because zinc is required for adequate hemoglobin production, but excess zinc can actually induce a copper deficiency, a micronutrient that is also vital for red blood cell production, and in deficiency states can induce anemia. Magnesium is very important for the enzymes required for red blood cell production. Vitamin D regulates inflammatory processes that can induce a functional iron deficiency, and also regulates iron absorption and utilization. Therefore, deficiency in either of these two micronutrients can also cause or exacerbate anemia. And we also see that thyroid hormones directly stimulate the production of red blood cells, meaning the essential elements for thyroid hormones, including selenium, iodine, and iron, when deficient, can all cause or worsen anemia. And outside of this, things like diabetes and low testosterone can also induce anemia, because diabetes is associated with inflammation, reduced iron absorption and utilization, and testosterone directly stimulates the production of red blood cells and hemoglobin. As you can see, even in a scenario of normal iron status, multiple other micronutrients and disease processes can induce anemia, even if your iron levels are perfect. And oftentimes this can be diagnosed using other biomarkers and taking a deeper look into the shape, size, number, and color of your red blood cells.